So let's continue. The other question we need to correct is this one here. So there's a scheme that we need to correct. So the starting material in this case is actually an alcohol. We look at that, we have the OH group there, having the alcohol functional group. That is what we have there. And then we again have that next compound, which is an aldehyde. When you look at it, it's actually an aldehyde because you have the CHO group there. You see, aldehydes actually are characterized by the presence of the CHO group. There's a carbonyl functional group, so it's an aldehyde that we actually have. And then the last part we have there is actually an acetal. If you remember very well, acetals are actually compounds that are formed when you react two equivalents of an alcohol with an aldehyde or a ketone. So that is an acetal. When you look at that part which is compressed at the end there, you can write it as there's a carbon there which was a carbonyl carbon, that's the starting material, so it will be attached to OR and also OR on the other group. So we are seeing the two outside there, so it's actually an acetal. Now let's go ahead and begin to correct this reaction scheme. Something is wrong in this scheme because even the question says there are some flaws that we need actually to correct here. What is happening there is actually oxidation. Now we have a primary alcohol. Now when you oxidize a primary alcohol using that strong oxidizing agent, we expect to get a carboxylic acid and not an aldehyde. So meaning, since we are getting an aldehyde there, what is happening is that the reagent we have there is actually a strong oxidizing agent, so it would give us a carboxylic acid over oxidizing an aldehyde. But in that case of an aldehyde, so it means we need to pick a weak oxidizing agent such as PCC or DMP, which is the Des-Martin periodinane reagent. So in this case, the correct reagent we're going to put there is going to be, let's use PCC, which is pyridinium chlorochromate, and not the chromium trioxide which was there initially, because that is a strong one to end up giving us a carboxylic acid. But since in this case we are getting an aldehyde there, so we need PCC in the presence of dichloromethane solvent there. So I've corrected that reaction scheme. Alright, then the other one we have is since we have an aldehyde there, and then we are converting that aldehyde into an acetal, so we'll actually need the two equivalents of that particular alcohol, which is methanol. So you add the first one, you get a hemiacetal, then you add the other one, then you get a full acetal. That is what we actually need there. So it's very easy to predict products, provided we have the concepts that we talked about during our previous lessons. So that is what we actually have. So the acetal formation taking place, then you have the final product there. So very easy. So just using the concept, of course, using the reactions, because we looked at all these reactions, the nucleophilic addition reactions, we looked at about 8 reactions, starting with hydration, all the way up to the Cannizzaro reaction. We also looked at the acetal formation. So it's very easy. We also talked about oxidation. I think almost everything.